My name is Michael Staib, and I'm a GraphQL Technical Steering Committee member. And my main topic under the GraphQL Foundation is the composite schema specification, which describes how GraphQL works in distributed systems. I'm also one of the founders of Chili Cream, and Chili Cream is known, for instance, for its hot chocolate GraphQL server that many people use in the .NET ecosystem. And apart from that, we also are building tooling like Nitro, which is our GraphQL IDE, and allows you to test your GraphQL endpoint or monitor your gateway, get insights into your GraphQL server, and inspect your GraphQL request on a trace level. We also do a lot of consulting work and help companies in their journey towards GraphQL. And as part of this work, we have seen a lot of design patterns that many of these companies are using. Today is kind of a reflection of that. So from smaller projects that use a database-driven approach to projects that use a slim layering, like a simple service layer where you do your business layer code in, where to larger enterprise projects that use enterprise patterns. So we're going to take actually this journey today. We start with a very simple thing. There's lots of code, lots of slides, and we start very at the beginning with a simple layered architecture and see how this can translate over time from clean architecture to CQRS to DDD, and really how this works together with GraphQL. Let me skip over that. And hopefully we will have, at the end of this, an answer to this question, if CQRS, DDD, and GraphQL are really a perfect fit, or if not. When companies move towards GraphQL, I always tell them that it's an opportunity to model an interface to their core business domain. GraphQL was designed by Meta, or I still call them Facebook, because I never get used to the name. Anyway, Facebook's intention was not that GraphQL was put on a data layer. This you see often when we go to customers, then you see GraphQL as just a thin layer over their data layer, basically a database-driven approach. You can do that for projects that you want to throw away after 3 months or 12 months or whatever, that don't have a long lifetime. GraphQL was also not meant to contain your business logic in the GraphQL layer and then model it on top of data layer. On top of your data layer. Back in 2016, Dan Schaffner, one of the co-creators of GraphQL, actually explained how Facebook is using GraphQL and why they designed it as they designed it. So what he explained is that in Facebook, GraphQL is just a thin layer over their business layer and exposes their business layer in a richer way. Instead of just exposing request and response patterns that you see in REST, they're exposing their business layer, their business model. Let me actually show you how that can look like. So this is a simple GraphQL server. I'm just starting it. We can have a look in a second how it looks inside from a code base. But let's just start it and have a look at the GraphQL schema. Okay, so this is Nitro, and we now see here our GraphQL schema. And you can see that we have here 2 types, query and mutation. And I can really dive into my schema here and look at what it can do. What you don't see is, like in a Swagger UI, certain requests that you can execute. But rather you can dive into a graph here. For instance, this is a web shop themed service. So I can dive into the brands that my web shop has here. And from the brands, I can go to the products and from the products maybe to the product types and so on. So you can really dive into your data graph. So this is your business model. You also have, when I go back here, yeah. You also have mutations, which are your use cases. Like, for instance, removing a product from the stock, from your inventory, when you sell it, right? This is modeled as a business case here, where we also see the errors that can happen in this business case. For instance, you are out of the product, there's no more stock of this product left, and you cannot sell it anymore. Or you don't have enough. The customer wants 5 items, but you only have 4. So you expose in your schema really your model. Okay, let's go back to the slides. So Facebook did a couple of design decisions that are important. Might be overwhelming in the beginning, but they make sense as we go along. So when we look at Facebook's business layer, they very early on had a thing that they called a data loader. A data loader is a tool for optimized data fetching. And it's really part of the data layer. It's a unified way to access a data layer and load data when you read data. In a mutation, you might get the data differently, but for reads, they had this optimized interface to get data from the data layer. And they really used that already with their REST API. So this was not invented for GraphQL, this was just invented that the business layer can more efficiently fetch data. The idea of the data loader pattern in Facebook was to have a component that provides a unified API to load data that transparently batches data requests into a single database call. So that data loader has something called a promise, right? A promise cache, which holds promises to data. So instead of giving you the data, a data loader gives you a promise to get soon that data you asked for. When the business layer asks for something that the data loader doesn't yet have in its cache, the data loader would just issue a promise. Here, soon I will have that. If it has it already in the cache, it will just return from the promise from the cache. And it does that. It does that to really optimize how you fetch data when you have multiple requests in a single user session against your data layer down the line. So when there's nothing else to do, then the data loader will go on and fulfill all these promises. So if you ask yourself, what is a promise here? It's basically a task in .NET. They just used a more correct word, and even Microsoft now says they should have actually called a task a promise. There are a couple of other enterprise patterns. Let's skip over that. There are a couple of other enterprise patterns that we have in Facebook that are important to understand how they thought about GraphQL and how this translates to your business domain. They, for instance, said that they only use something called cursor pagination, which translates to key set pagination in normal language. Does anybody know what key set pagination is? Okay, no. Offset pagination? Okay, a couple of. Okay, so key set pagination is a way that you don't skip over data in your database to have really fast access when you page through data. So with offset pagination, what you do is you execute something on the database, and then you're skipping over the result until you get to the section where you return data. This is expensive. Think about the newsfeed of Facebook, which is really long. You can scroll forever. And the more you scroll, the more expensive this would get with offset pagination. What key set pagination does is really filter in on the section that you need, and then just take 10 items maybe from it. And with that, you have constant performance over pagination. The second pattern that they used is something called a mutation convention. This is basically a design pattern how these mutations look like. We're going to look at that. And the third pattern And just keep it on your stack for now. It doesn't have to make sense yet. The third pattern that they used is something that they call a global object identification spec. And that is about entities. Okay, let's really get started with our journey. The first part of our journey is to build a software that lasts. Because when we look at clean architecture, why do you do all this complicated stuff? Is because we want to create software that lasts longer than 3 months. And we want to maintain it longer than 3 months. So if you're building a to-do app, you don't have to do all this stuff. Although most examples will show you a to-do app. Clean architecture is an architectural style that is well established within the .NET community. Often it's mixed together with DDD and CQRS, but all these things are different things. Clean architecture seeks this separation of concern and introduces high modularity by introducing a clear layering to your application. We do that in enterprise applications to be independent from external components, like your database or a certain framework, for instance, entity framework, or whatnot. There's always a decision you can take, how much independence you really want from that. For instance, Jason Taylor, who also does a lot of talking about clean architecture and has this nice template in .NET, made the architectural decision to have entity framework as a framework within its domain layer. It's a decision you can take. But in general, we want independence of these frameworks to be able to move our software over decades maybe to other frameworks. Have it evolvable, right? Let people swap out things. And there's often the argument that actually something like a database you never swap out. Actually, I work on a project where we have the third database now, the third database swap out. We went from Mongo and then tried a bit Cosmos, and now we are at Postgres. So these things can happen depending on your performance needs or other data needs that you have. Let's have a look at the layers here. So does anybody know what the domain layer is or what goes into the domain layer? Okay, a couple of. What's your idea?
Something that's independent of code, but actually something that happens in the real world that you want to model.
So the clear definition is the domain layer contains your core business domain, your core business rules. Typically, what we put in here are the entities, value objects, aggregates, services, or events. We will have a closer look at this as we are taking our original simple layering project that I actually have here. And we're going to move that, and here you can see everything is basically in one project, and we're going to move that into separate projects and reorder it. Okay. The next layer is called the application layer and encapsulates your use cases and orchestrates interaction between entities. So what that means is that the application layer basically defines your use cases. So when you, for instance, check out an order or you remove something from the stock, that is a use case and that interacts with your entities. Next up, we have the infrastructure layer. And this is, while these two layers almost never change, right? They are very stable because this is your business domain. The infrastructure layer can change. This is where all the technical stuff lives, like the dependence on entity framework, or that you use a certain file storage, or your queue that you're using. When you look at the diagram for implementing this, you, for instance, define in your domain layer the repository as an interface. And then you would implement the concrete interface in your infrastructure layer. The important thing is that when we do that, and when we reference things, we always reference from the outside to the inside. For instance, the application layer references from the domain layer, and the infrastructure layer can reference both the application and the domain layer, but the domain layer never references the infrastructure layer. And also the presentation layer in this case can reference the infrastructure layer and the application layer, but also the inner layers cannot reference outside. Lastly, we have the presentation layer, and the presentation layer, that's where actually GraphQL sits in. In traditional technologies, you could also have your web pages in there if your business layer is hosted in your Razor application or whatnot, or other things. But once you choose GraphQL, that is basically the only thing that is your presentation layer. Let's actually have a look at how we can translate the project that I have here, and let's quickly go through it and see how it changes once we put clean architecture into it. So this is already a very clean project, and if you're doing that in a single application, it's already good. So we have here the data layer, which is entity framework here, and at the moment we have basically 3 entities: products, product types, brands. It's basically the application I showed you. And then we have here the models, and we also have the services. These services here, let me just collapse that and make that a bit bigger. And if you cannot see, just shout and I will make it larger. So we have here, for instance, let's look at the product because it's more interesting. When we look at the product service, we have here something that are fetch calls. These guys here, they just fetch data. And then we have also use cases, our mutations, like creating a product, like updating a product, typical CRUD here, but also more concrete, like remove stock, for instance. And remove stock also has proper business logic here. In this case, just validation. I wanted to keep it simple. So we basically look at the quantity that is desired. If it's negative, we don't allow it. If we don't have any stock, we don't have to do anything anymore. Or if the quantity the desired quantity is larger than the available stock, we just accept here. So this already business logic, just that we have it encoded here in services. And then we have a GraphQL layer, and the GraphQL layer is really a thin layer over our existing business layer here. And let me quickly go here to the operations. So the GraphQL operations represent our entry point into the system. And what you can see here is, for instance, that you have the get product by ID, and that just calls our business layer to get the product. So very thin. We don't want to have any logic in here. We just refer to our service. Same goes for if we go to a mutation here, and let's go to the remove stock mutation. 1 second. There. That is the remove product stock, which is wrongly implemented. It says add stock, but I might have tested that. Okay, but this maps just to remove stock, so it cleanly maps to our business layer. So GraphQL is very simple like that, right? It's not a lot code that you have here. It's just basically defining the hooks into the system. Okay, so this is just the product where we started. So if we go over it and we would remodel it, let me close that and look at the clean architecture version of it. 1 second. Awkward. Make it wide so it's better viewable. Okay, the clean architecture version now has multiple projects here where I reorganized it. So I have now here the API layer. That's my presentation layer. That's where GraphQL sits. And if I look at that, it's basically the same. So everything that I had in the GraphQL layer is there like before. I have the operations. They just call this service. Okay. And then I have the domain layer. That is the innermost layer. So I reorganized it. And we now have here the entities, and you can see here's my product entity, and I have a product repository where I can do my actions against. The repository in this context is mainly to mutate the data in my system. So I can get the product, then I could update whatever I did to the product, delete the product, and whatnot. And then the model is basically the same as before, a simple model for entity framework. Okay, let me get rid of this. Okay, then we have the application layer. And the application layer has the business cases, as I said. So this is basically where we have now our services. So if we go here to product, you can see that I have encoded here my services. And if I go into that, you can see that we are injecting up here the product repository that is for mutating data. And here you see the batching context that are all the data loaders I use here. So I'm using the data loaders in my application layer. And that's one of the design decisions that why I pointed it out in the beginning, to have a more efficient data fetching in a graph. We can have a look at execution times later on that. So what we basically do, and you can see here the unified API for a data loader is always a load async. So we take the data loader, we load. So this is a unified API that we have here. So for my mutations, and let's again go to my remove stock mutation here. We basically now use the repository that we designed in our domain layer. We fetch the product. We have still the errors here. Looks almost the same as before. And then we update it. And we also have here a unit of work that we can invoke. So I completely abstracted entity framework from my system. And that actually I designed down here in the entities. If you look at the product repository, this implements the I repository, and here I have the unit of work. So that translates well to entity framework, but I don't have any dependency in these two layers to entity framework itself. This all sits here in the infrastructure layer, and that's also where I implemented the data loader. In the application layer, I only have interfaces for that. But then down here, I have concrete implementation for these data loaders, how they batch fetch things. Basically, you define here, okay, if you get these batches of ID, this is how you get it out of the database. Same goes for, let's quickly have a look at that. Same goes for the entity configuration for entity framework here, or the catalog context. It's all in this layer. Okay, let's move on a bit. So that's about structuring your API. If you think about commands and all this stuff, that's actually not clean architecture. This is where we talk about CQRS, which is a different thing, right? With this new layering, we already introduced clear separation of these components and of your business concerns, but we are still missing modularity. Think about the services. In the services, I have my read concerns, so reading the data, but also all the mutations co-located. And this is kind of messy because I have to inject all the data loaders in there. I cannot test them independently, and this doesn't feel right. With CQRS, there exists a design pattern which lets us solve this problem. CQRS stands for Command Query Responsibility Segregation. I always get that wrong. But it basically separates reads and writes. And that's also why I showed in the beginning, GraphQL is designed for that, right? If we look at our schema, then you can see already from the basic design principles, Facebook had that in mind. So they have queries that are side effect-free reads to your system, where are mutations that cause side effects to your system. Okay. Go back to the slides. Okay, let's dive into that. So with CQRS, we have a task-based interaction. So each of your use cases, like checkout, remove stock, are designed as commands. And each of these exists in isolation. Queries, on the other hand, represent side effect-free reads, just like in GraphQL, right? They are purely informational. We want to be able to scale our reads independently from the writes. And if you think about that, this is often the case. Like mutations are slower, like changing data is often slower because you need transactions and whatnot than reads. And technically, they could sit in different locations. Think about NuGet, for instance. They have these persisted JSON documents, which are really computed out for a lot of use cases, but then they have an SQL server where they write the data in. So they write into the SQL server, and then they create a read model for that asynchronously. You don't have to do that with CQRS. You can have everything in the same place, but the mindset is there that you separate it. So as I already hinted, a command is in GraphQL called a mutation. And if we look at the mutation structure here, then there is some difference to the clean CQRS that you see when you read up on it. Let's have a look at this. In GraphQL, mutations can only be top level. That means this top thing, create product, that is a mutation. Then the input that you pass in, that represents the write model, basically the data you pass into your command. And then we have down here the read model, and that is different to standard CQRS, because standard CQRS, you don't get a read model back. But in GraphQL, the idea is you do a mutation, then you read the impact of that mutation and update your client components. So you have a single call to your system, do the change, and read the change so you can update your client components. Sorry. This is for efficiency, right? Okay. So as I said, CQRS embraces eventual consistency. So you don't have to design GraphQL specifically like I showed there. It's the best practices, and it would make would make things so much simpler. But if you have something like NuGet, where you really need eventual consistency, then this is also possible with GraphQL. You design the mutations slightly different, and I can show you that. What you should keep in mind is, if you do eventual consistency, it will add complexity from your UI layer down to your data layer. So in this case, we have, again, a mutation here, slightly different mutation, add a stock to a watch list. And what we do here is basically we do the mutation and we get back a transaction ID, and then we can use something in GraphQL which is called a subscription, which is subscribing to events of your system and then executing a query here. In this case, we are subscribing to the onto watch list. I don't know how I wrote that, but yeah, you're subscribing to that event on add something to watch list, and then you get the watch list back once it's completed, and you could update your client store again. So this is the third operation kind that GraphQL actually has a subscription. Let's talk about queries, because that's simple. Queries in GraphQL are just queries in CQRS. And that 100% aligns. And also aligns from the idea, side effect-free reads, fast reads. That's where it's optimized for. Okay, let's actually have a look at how this changes our GraphQL solution. So this was a bit about, clean architecture was a bit about where do we put things, where the CQRS change will really have an impact on our system. So let's go to 3. Okay, 1 second, make it wide. Okay, So here we have the same thing, so same setup. We have clean architecture here from where do we put things, but now we also have CQRS here. And that changes a bit where things live. Like the domain layer is actually the same. But when we look here now at the application layer and look at products, we have a lot more things here. Like for instance, we have commands. Commands are our use cases. And we looked, for instance, at the remove product stock use case. And it's now designed as a single class where we have here our write model. That's what we pass in. Think about the input, right? And there we define the product ID and the quantity desired. That is passed into our handler, and I'm using here mediator. In my application layer, I said before, we want independence of frameworks, but I did the architectural decision to use mediator because otherwise I would re-implement mediator. So you always have to reflect how strongly you want to be independent from certain core frameworks, right? But that's up to everyone that designs their software to decide really what are core components. Okay, in mediator we have the request handler that handles the commands, so it basically gets this in, and then this is our execution of this command. And this is basically the code I had before in my service. But now it's independently testable because I have a single class here, and it also has a much clearer injection requirement for dependency injection because I only require the product repository. I don't need the data loaders because for this use case, I don't need data loaders, right? Okay. Quickly go. Yeah, the other thing here is, as I said, in GraphQL, we return a read model, and that's what I do down here after I mutate it. I basically have the product that I mutated, and then I just map it to my read model. This is basically just hard mapping onto the read model, which is slightly different from my write model. And as we go along, it changes even more. Okay. The other thing is that we talked about queries, right? And queries are down here. So I misused a mediator a bit. I could also design my queries as simple classes, but because I already have the structure in here, I just reused it. For instance, I have the get product by ID query here, which implements iQuery, and that implements basically a request from mediator. So why do I do that? Does anybody know mediator? Some? Okay, so in mediator you have behaviors. And these behaviors are actually nice because they are cross-cutting concerns, like transactions in a database. And let's actually have a look at that. I have here in the common of my application layer defined the behaviors. For instance, here's the transaction behavior. So every time something goes in my pipeline, a command, I will create an execution strategy that makes sure if the database is not there, we retry it with exponential backoff. And we also have a transaction around that. And if something goes wrong, we just wipe the state and re-execute it. Okay, but for a query, this would be like not good, because the query would be slow, because we open every time a transaction on the database, then execute within the transaction just to read. So what we do here is just filter out if the request is a query, we just execute next. Sorry, I have a cold. Short on time, let's move on. So this is what the change is here with the query. So we now have the same infrastructure that we can reuse mediator here to write the queries. And this is also very clean. I could make it a bit cleaner because I wouldn't need to inject here the product batching context, which is all the data loaders for product. I could also change that a bit and just inject here the specific data loader for this read use case, which would be cleaner. Okay, the other thing is when we go now to our operations in the API layer, like this, actually barely changed, thin layer, over our business layer. But if we go to the operations here, then what you can see, and this is the remove stock case, is that we are now injecting here mediator. Then we are just saying to mediator, here's a remove product stock command, and inject that into the pipeline, and then we get back our read model here. And that we get back a read model is defined here in the query, in the request, because we have here the response that we get is the product, and that is the input. Let me show you one more thing, because like what doesn't come here out very clearly, because this is such a simple thing, is that you actually can use as an input just, this is a hot chocolate thing, you can say, I'm using this command here as an input, and what our GraphQL engine will do is just take this input shape here and apply the GraphQL best practices on it, and then this is just the input shape for the user. So if I go and we run that quickly, let's run that and look at the schema, then you can see that this will just be transparently what the user can pass in. And that is very nice because you still have this thin layer. Yeah. Let's see. This was the create product. And you can see this is now the product input. And basically all the properties that I have on my command are just reflected here as a write model. That's why I had this initial diagram there. Okay. Let's actually move on. Okay, this is CQRS. And it gives you a lot of flexibility, makes it easier testable, and allows you to change your data fetching mechanisms as you go along. As you scale further, you might want to have a separate read model to just answer things faster, and also allows you for eventual consistency down the line and so on. Let's talk about domain-driven design, or short DDD. DDD is a strategic design approach for complex applications. So it's not meant to design your to-do app, like I initially said, but most examples are actually a to-do app. DDD helps focus on core business problems by aligning software models with business requirements and using a shared language between developers and domain experts, stakeholders. And it's called the ubiquitous language. Understanding your business is key for applying DDD, but it's also key for writing successful software projects, right? If you don't know what you're writing software for, if you don't understand your domain, then it's getting difficult, right? So the idea here is to simplify complex systems and turn them into software, into maintainable, understandable software. So what's the ubiquitous language that I said? It's a common language, common terms that you make up to describe your business, right? So it could be checkout product, that this is part of your ubiquitous language. So a model that you can describe what you do in your business day to day, and that translates into logical names of your software components. And it's understood not only by your developers, but also by the stakeholders or the domain experts. So does this sound familiar? In GraphQL, we call the schema actually, this guy here, we call that the ubiquitous language, because that is what Facebook intended. This is your business model. That's why we have so many constructs like interfaces, unions, and whatnot. So you can describe your business model. It's a layer that, with a simple to understand model, describes your business. The names you use in your schema should be clear terms, very close to DDD. Mutations describe the business cases you can invoke. We recommend people that are starting with GraphQL to actually set up initially schema design meetings. Actually keep them. Do them always. Schema design meetings. And the reason for this is GraphQL has a super nice schema language, this guy here. It's easy to understand between developers, like front-end developers and back-end developers. And also you can reason about it as a business guy with a bit of training. But it's a great document that you can work on in these design sessions to pin down what your design should look like. The core building blocks of DDD are entities. We already heard about entities, right? Value objects, aggregates, and repositories. That's basically terms we already use in our new structured project. In DDD, entities are objects that have a distinct identity that persists over time and across different states, meaning the identity is more important than their attributes. So I talked initially about something in GraphQL that's the global object identification specification. This guy here, basically a node is an entity in DDD. And in GraphQL, the importance of the identifier is even greater because it's schema unique. You can give a GraphQL server just the ID of a node, and it will know the type of the entity type and can resolve you just the entity that you ask for without you specifying that you want this entity. Okay. An aggregate in DDD is a cluster of related objects that are treated as a single unit when we persist it. So for schema change, it's persisted as a single unit. If you think about the order items and the order may be an aggregate that you save in one go to the database. In GraphQL, it's irrelevant, so we don't have this kind of a thing, because how you save an entity doesn't matter to the outside world. This is a technical detail that you have in your C# code, but not in your schema. So aggregates and repositories. Let me skip over that. Yeah. So what you can see here is a bit the mapping. So entities, nodes, value objects are scalars in GraphQL. And aggregates, it's just types because they have no relevance. And repositories, also implementation detail, how you do something, so we don't have that. So with GraphQL as the API layer, in front of your applications and domain layer, there's no need for different representations. The business model is exposed to your clients. And you no longer need BFFs because each client can choose actually what they need from your backend, can choose what they want to interact from your backend with. Let me skip over that. There's one more thing. We can have a look at that in a second. Time is running out. I just want to show you how this actually translates now to, I actually had 9 demos. I think we won't make it. But we are at 4 now. Okay, so this is our DDD project. I just sprinkled some DDD on top of that. It's not fully because we don't have events yet. But let's have a look at it. So again, same structure. What has changed here is actually the domain layer. And if we dive into the entities, then we can look at the product here. And do you remember the remove stock? Remove stock is actually core business logic. And we can look here at the product now, and you can see that we now have here private sets because you cannot change it from the outside. You can just interact through methods through it. So I have here, for instance, a rename, a change description, change price, remove stock. This is the business logic that we had before. It's now just on the entity, and it doesn't do the save. So now I have the business logic encoded in my entity. So this is now clear structured. And then if we go to our application layer and we look actually at the product here, at commands, and then at remove product stock, this is also now much clearer. So we basically took it more apart, made it more modular. Now I have the Azure business logic on my entity, and then the command, which basically gets the product, then removes the stock, and then persists it to the database. So this allows me now to validate my business logic on the entity just in memory, see if it works. I can test all the business cases there. Then here I have the flow, the interaction between things. Also separately testable. You can see it's a lot about testability, maintainability, and to allow you to more easily upgrade your system over time. Okay, I have maybe 1 minute. That's not a lot. Okay, let's get to the end. These were all the slides I had for you, but okay. Yeah. So we actually have lots more of this information. You can hook up to us. At this repository you find all the GraphQL magic. And we are at the moment really producing content around these enterprise patterns more and more. So you can reach me on Twitter or on Blue Sky or wherever you want to be. And you're also invited to just ask questions if you have.